Section 10.1, the ellipse. In this section, we'll write equations of ellipses in standard form. We'll graph ellipses centered at the origin, and also ones that are not centered at the origin. So in this chapter, we study three shapes which are called the conic sections, and they're the shapes that we get when we slice a cone with a plane. And the first one that we're going to talk about today is the ellipse. So you can see that it's this shape right here, kind of an oval shape. Another shape that we'll take a look at is the hyperbola. So the hyperbola is going to have two pieces to it. And then the final shape we'll look at is the parabola, which is probably the one you have the most experience with, and that's the shape there. All right, so let's start talking about the ellipse. So the ellipse is a set of all points in the plane such that the sum of their distances to two fixed points is constant. So these two fixed points in the plane, and these are called foci, so those are the fixed points. And what's true about every point on this curve is that if we were to measure the distance to the first focus and the second focus, so first distance and the second distance, if you add those two distances together, it's the constant, it's the same for any point on the ellipse. So if I added those two distances together, or I took another point on the ellipse and I added this distance and this distance together, or if I took another point on the ellipse and added this distance and this distance together, when I added those together, we would always get the same number. Okay? Some vocabulary associated with the ellipse. We already talked about the foci. The vertices are these endpoints here. So an ellipse is going to have four vertices. It has two axes. One is called the major axis. So the major axis is the longer axis. And so the major axis of this ellipse would be horizontal. The minor axis is the shorter axis. And the minor axis in this ellipse is vertical. And they can be reversed. You could have a longer one vertical and a shorter one horizontal. All right. So in this section, we're going to be learning about how to graph ellipses and how to describe their important features. So the standard form of ellipse looks like this. The standard form is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And I'm not going to derive that for you, but you can look at the derivation of that formula if you're interested in your textbook. Now, your textbook gives two formulas for the equation of ellipse, and I've always thought that that was just a harder way to remember these. So you can just use this one standard formula, and I'll show you how to use it for the two types of ellipses that we have. The center is going to be the point h comma k. To find the vertices, you take the square root of the denominators to find the distance to the vertices from the center. So the center of the ellipse is right here where the major and minor axis cross. Okay? And the distance to the foci from the center is the square root of the difference of the denominators. All right, so let's take a look at an example to see if this makes sense. So here's this ellipse, x squared over 16 plus y squared over 9 equals 1. And we'd like to graph this ellipse. Okay. So the first thing we're going to do is we're going to find the center of the ellipse. Now remember, the center of the ellipse is the point h comma k. So you ask yourself, what is being subtracted from x and what is being subtracted from y? Well, nothing's being subtracted from x and nothing's being subtracted from y. So we're starting with an easy example where the center is at the origin. Now we're going to find the vertices. The way to find the vertices is you take the square root of the denominators. So the square root of 16 is 4. So in the x direction, from the center, we're going to move 4 spaces. 1, 2, 3, 4. 1, 2, 3, 4. So those are 2 vertices of the ellipse. The square root of 9 is 3. So in the y direction, we're going to move 3 units. 1, 2, 3, 1, 2, 3. And now we have our vertices, and we can do our best to draw in something that looks like an ellipse. Some features of the ellipse that are often asked about is the coordinates of the foci. So the foci, we should say, are always found on the major axis. So if we look at this ellipse, we can see that the major axis is horizontal. And the foci are going to be located somewhere along that major axis. Now the distance to the foci from the center is the square root of the difference of the denominators. So 16 minus 9 is 7. So the square root of 7. Now the square root of 7 is somewhere between 2 and 3. So here's a focus, and here's a focus. And what would the coordinates be? The coordinates would be of this one, negative square root 7, comma 0. And of this one, this would be positive square root 7, comma 0. And that's a graph of the ellipse. If we were asked how long is the major axis, we could just do that by sight. The major axis, the longer one, is horizontal, and it's 8 units long. The minor axis, the shorter one, is vertical. And if we look at our graph, it's 6 units long. Okay, let's try another one. X squared over 4 plus y squared over 25 equals 1. So again, we're going to find the vertex. The vertex coordinates are the numbers being subtracted from x and y. And again, in this example, we can see that nothing is being subtracted from x and y. The next thing we'll do, I didn't mean to label that as the vertex. I meant to label that as the center. Okay, so we have a ellipse that's going to be, again, centered at the origin. So we'll go ahead and we'll get started with our graph, and there's the center. Okay, so now we have to find the vertices. So we take the square root of 4, which is 2. So in the x direction, we're going to move 2 units from the center. 1, 2, 1, 2. We take the square root of 25, which is 5. So in the y direction, we're going to move 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And we're going to join these together as best we can to make our graph look like an ellipse. All right, the last thing we'll do is we'll find the foci. So the distance to the foci is the square root of the difference of the denominators. So if we take 25 minus 4, we're going to have the square root of 21, which is somewhere between 4 and 5. So let's go ahead and we can graph the foci. So 1, 2, 3, 4, and a little bit, there's one out there. 1, 2, 3, 4, and a little bit more, there's one out there. If we wanted to give the coordinates of this focus would be 0, comma, positive square root of 21. And the coordinate of this focus, again, the x coordinate is 0, and the y coordinate is negative square root 21. If asked for information about the axes, the major axis, the longer one, is vertical, and it's 10 units long. And the minor axis is horizontal, and it's 4 units long. Okay, what happens when we have an ellipse that's not at the center, centered at the origin? Well, let's do an example. Okay, so we take a look at this one. The first thing we're going to do is we're going to find the center, and we ask ourselves, what is being subtracted from x? 1. What is being subtracted from y? -2. So this ellipse is going to be different in that it's going to be centered at 1, -2. All right, so we'll go ahead and get started to graph this. So at 1, -2, there we have our center. All right, now we'll find our vertices. So let me stop there and see if you can fill this in. In the x direction, how far are you going to move? And in the y direction, how far are you going to move? Okay, so hopefully you said in the x direction you're going to move 5 because that's the square root of 25. And in the y direction, hopefully you said 3 because that's the square root of 9. So you just look at the number which is under in the denominator of each of those terms, and that tells you where to move. Now remember, start from the center. So from the center, in the x direction, we'll move 5 to the right, and we'll move 5 to the left. So there are our vertices. We'll move 3 to the vertical up and 3 down. And so here we have the vertices of our ellipse. The next thing we're going to do is we're going to find the distance to the foci. We're going to take the square root of 25 minus 9. That's the square root of 16, which is 4. Now remember, the foci are located along the major axis. So see if you can come up with the coordinates of the foci. Remember to start counting from the center. Okay, so now let's check your work. The foci, if we go 4 to the right, we're at this point here. The coordinate of that point would be 1, 2, 3, 4, 5, 5, -2. And from the center, if we go 1, 2, 3, 4, we would be at this point. And the coordinate of that point is -3, -2.